On the previous slide, we showed that the solid phase is stable at the lowest temperatures and that upon heating a crystalline solid, we can form liquids at intermediate temperatures and vapors at the highest temperatures. We know from experience that this may not always be the case, since solids under specific conditions can sublime to form vapors. To understand how this may happen, we need to think about the effect of pressure on the molar Gibbs energy. This effect is understood from the equation dGm equals Vm dP, which tells us that if we decrease the pressure, that is for a negative dP, then we must decrease the molar Gibbs energy, since molar volumes are always positive. We know that the molar volume of the solid is in general smaller than that of the liquid, except of course for water around 4 degrees Celsius, and that the molar volume of liquids is always much lower than that of gases, by a factor of 1,000 or so. These observations imply that for a given decrease in pressure from P1 to P2, the decrease in molar Gibbs energy should be smaller for the solid than for the liquid and should be much smaller for the liquid than for the gas. Consequently, a decrease from pressure P1 to pressure P2 will result in a downward shift of all molar Gibbs energy versus temperature curves, more so for the liquid than for the solid, and much more so for the gas than for the liquid. We can now answer the question we raised on the previous slide regarding the effect of lowering the pressure on the phase transitions observed during heating. Upon decreasing the pressure from P1 to P2, we see that the solid state is still the most stable phase at the lowest temperatures. We also note that the gas or vapor state is the most stable phase at higher temperatures. So this indicates that upon heating a solid at sufficiently low pressure, the solid phase sublimes to form the vapor phase. We also conclude that the liquid phase is no longer stable at any temperature, since its molar Gibbs energy is always greater than that of the solid or that of the vapor. Hence, the melting and the boiling transitions are no longer observed.